Ladies and gentlemen, thank you very much for your time, your valued time. It's very valuable to us. Myself, I'm Roger Blewett from AAM, Business Development, and today we'll be sharing a little bit about what we're doing in the geospatial industry in terms of mine planning, optimization, rehabilitation. So I'll be sharing on some case studies of how we're going about that. Recently, I was in one of the best locations in the world, Sabi Sands in Mpumalanga. And we were at a specific camp, and I was walking along, and the one gentleman asked me, "Who are you? Where are you from, and where are you going?" And I realized this is probably one of the most important questions anybody has ever asked me, for myself and also for the company, and I suppose the industry and also the mining sector. Last week, Wednesday, I was sitting in one of the oldest pubs in South Africa in Kimberley, Star of the West. And we were talking on some of the different technologies of how mining has really moved from back in the 1800s to now, from that Kimberley hole to where we are now. I'm sitting in Mining Indaba 2014, of how the mining sector really has grown in Southern Africa and Africa. So AAM, who we really are, stemming from 1931 as AOC Geomatics, doing airborne surveys throughout Africa. And as of lately, a new company, Global Geomatics, also on board now from the ground survey side. We've now really come together to form AAM Africa, part of the AAM international group of companies. Just briefly, if I can quickly go and give you a bit of background as to who we are and what we do. We really take a solution-centric approach to business and to mining and anything we do in terms of geospatial information. So we look at the big picture. We really do what we call a A to Z solutions providing service, from satellite capture through to airborne surveys, LiDAR surveys, imagery. And then now we know this whole UAV thing is coming into place. So that's something that we're definitely spending a lot of our time and energy in R&D for UAVs, not in South Africa because of civil aviation regulations, but definitely in Africa. We're using some of these UAVs from remote locations where it's difficult to get to site. The products that come from all of these really are your digital elevation models, your good high-resolution imagery. Something new to us, which I'll be discussing a little later in this presentation, is bathymetric LiDAR and bathymetric survey, underwater, shallow water surveys, is now really part of the mix in terms of what we do. And then terrestrial LiDAR, your conventional surveys, mobile laser scanning on mines, pit volumes and all sorts of things, dump volumes. And then you've got all this brilliant content, but how do you view it? And we're really taking that to the next level in terms of visualization technology through 3D GIS, web GIS, and then finally oblique imagery. That's really being able to measure heights of buildings and things using oblique technologies. We are also very safety conscious, so we make sure that safety is first priority, and have been awarded as part of the group some prestigious awards in terms of safety in the last few years. We've got offices throughout the world: New Zealand, Australia, Southeast Asia, now lately in Hong Kong, Kuala Lumpur. Later, a new one really coming about now is in India, and then in Africa, South Africa, Johannesburg, and then some satellite sites that we're looking to develop, and is really in West Africa and East Africa. So those are areas that we're really spending a lot of time and energy. On the sort of job creation side, we've got a Centre of Excellence down in Cape Town, where all of our work from Australia, Asia, is sent to our Cape Town office for processing. So we're creating jobs in the South African environment as well. As I was saying, where we've come from, who we are, and where we're going, and this is really the next part of it, is this geospatial information technology. Really, there are three major technology trends at the moment, three technologies that are really booming. The one being your biotechnologies, the second being your nanotechnologies, and thirdly, your geotechnologies. And that's exactly where we find ourselves at the moment. You've got your Apples, your Googles, Google Maps. You can go in there, you can see Street View, all of those wonderful things. And we need to keep up with that. We find ourselves over here. This is now from the Kingsley report. A Kingsley report, technology top 500 companies industry, and software is right up there. 50% of the top 500 companies growing, and we really finding ourselves in part of that as content and serving content over the web as software as a service. So visualization is an important key as well in terms of this mix, and that's something I'll be talking a little bit about in this presentation as well. Just a couple of pointers here. It's amazing actually what's going on in the world at the moment. 5 billion mobile phones in use in 2010. I don't know, we'll probably be at about 6 million now, 6 billion, 30 billion pieces of content shared on Facebook every month. Global industry analysts predict that the GIS market will reach 10.5 billion by 2017. And this has all got a big impact on the mining sector and visualizing your data and actually using it effectively. One of my heroes and somebody I listen to and read quite a lot is a guy called Lewis Pugh. He's a swimmer and a conservationist. And he said that visualization closes the gap between where you are and where you need to be. And that's exactly where we find ourselves now in the AAM group. We've got content, we've got this LiDAR information, underground detection information, and we need to actually visualize this thing and show where we need to be in terms of future development. So moving on to a case study, as mentioned in the title, I'd like to just discuss a specific project, a case study that we've done recently in West Africa. The case study was for a gold mine up to the northwestern parts of Accra, all the way up here. Mine 430 square kilometers, processing capacity of 3.5 million tons a year. And really how this came about was through expansion. They're looking at big expansion projects up in that part of the world. Another big problem for them was vegetation coverage. They've got a lot of vegetation there. They've got big forests and trees, and they need penetration of that to see actually what's happening on the bare earth. With that as well is environmental compliance, and that's something I'll also allude to. The problems really that they were facing was number one, the planning for tailings dams. So they need to expand this mine, and where they're going to expand to was the one problem. Secondly, environmental compliance, timing delays. They've got obviously investors all over the world, and they need to make money. So timing was of a key problem to them. And then the economic implications. If they delayed time, the gold price is down, and all sorts of things. They need to stay abreast of all of those at the same time. So really, what are the challenges that we faced there? As we all know, West Africa is not the easiest place to work. You've got weather complications. December, January is really the only time of the year that you can capture up there, good weather windows. Other times of the year, you've got the harmattan, you've got really hazy conditions with cloud cover and just a lot of precipitation being on that sort of equatorial belt. So it's quite difficult. You've got to choose the time of the year quite carefully when you're doing your planning. There's our aircraft that we flew up there from our South African base to our Ghana, and we actually landed on site on the runway on site there and had fuel in place ready to do the survey. Here we've just done a little bit of clearing to do pre-marking on the ground for the processing purposes. And then this is really just a bit of an idea of what it looks like in that part of the world. What were the outcomes, and how did we solve these problems that the clients were facing? Firstly, we were using the mid-format camera and also LiDAR systems to fly the whole mine at 430 square kilometers. That we did within a period of, I think it was a week that we were up there. And then we processed the data. It was about an 8-week project and had it delivered. With the delivery, we had software that we also delivered with that, and we did specific training on that. And then we also exposed this over the web. And as I was saying earlier, we're talking about content, and we're talking about sharing of data. And in this current environment, you've got investors, you've got shareholders, you've got stakeholders all over the world that need to be able to visualize this data and see actually what's going on the earth and what's going on in these specific mines. So we actually built a web application for the specific mine, and that's then served through a web through hosting and served through the whole mine, and they can actually use that link, and we've actually gone and created and captured all sorts of information on the ground, such as power lines, roads, building footprints, all sorts of things. And over here you can see we've got some good coverage of your tree canopies, and then also ground cover with a LiDAR, so they could actually do very accurate planning in terms of their mine dumps and how they're going to be expanding. Really, it didn't stop there. The next phase is to do annual and also monthly audits of their actual pits and their stockpile volumes, and there we're using UAV technology to go in there, which is a lot more cost effective. But it will not suffice to capture the whole area. It's just too big. So for the smaller little areas where you haven't got much vegetation, UAVs are definitely a technology to look out for, and something that we're using within the AAM group. Just one of the comments that one of our clients made was that he said the right technology over the right target is what AAM has been giving them to get the best outcome. One back. This thing's stuck. So really, in conclusion, in terms of that specific case study, what we did was rapid deployment in difficult environmental conditions, continuous monitoring through the UAVs, high-resolution imagery, vegetation penetration, conforming to local projections, which was also very important for them, is that we conform to their local projections, site selection and optimization, software training, web deployment and support. And really what the client said was that AAM was one of the best professional teams you could have, with a good understanding of the client needs as well as the patience to work through with them from imagery capture stage to the data processing and delivery to after delivery consulting. And that's what we find is valuable. Secondly, a last case study on a volumetric survey that we've done recently. This was for the Tarong Power Station. And this was quite a unique actual setup where they needed to measure the submerged ash as well as the exposed ash. So here we used a new technology. It's a little Z boat that we've bought and that we're actually using. You pre-program it as you would do with a UAV, and you drive it up and down the dam, and you get brilliant feedback. So what they actually wanted to do, the situation behind that, was really to monitor storage capacity, and then also to assist with the planning and design of rehabilitation on that specific site. So that was one of the good outcomes of that, and the benefits that really came from it was the elimination of the safety concerns of having a manned boat on the actual lake, a water boat, and accurate data collected in terms of the dam, which could be difficult or impossible to reach with conventional dinghy outboard motor setups. Some of these parts are very shallow. A system could be mobilized to site quickly, allowing rapid data acquisition, and then complete measurement up to the water ash interface. And then what we did was we flew LiDAR over this whole area, and we did the underwater, and we put together a full data set of actually what is happening on the ground, a combination of airborne and waterborne LiDAR. Just lastly, and this is really where we're going in terms of the future development as AAM, we also working with some of the universities and some of the technology specialists in visualization and also simulation in terms of what does our world look like. So this typical pit-to-port type survey, where you're capturing mine sites, you're capturing volumes, and then actually on vessels you can measure anything from the smallest nut and bolt to the biggest port area through different technologies that we're using, from terrestrial to airborne LiDAR. And then of course your bathymetric LiDAR, and then simulating. This is the port of Buffalo City. It's Port Elizabeth. Really, this specific port. So really, that's in concluding who we are and what we do, and I just want to thank you very much for your time. Our stand is at 2003. You very welcome to pop by there. We'd like to listen to your specific requirements and what you do, and our website is www.aamgroup.com. Thank you very much.